Hello friends, how are you? Today I will not describe about any synthesis, but I will discuss about an unexpected incident with this chemical para-Trifluoromethyl aniline. The incident was reported by a pharmaceutical company from USA. The name of that pharmaceutical company and the reference I will be mentioning at the end of the video. Now briefly I will describe about the incident. So they procured 20 kg of this chemical and received in liquid form. Chemical was stored in a poly drum. That time they did not receive any special instruction about the storage of the chemical. Only information they had, like melting point of the material is 38 degrees Celsius and boiling point is 83 Celsius at 12 mm pressure. So they kept this material in warehouse, and after 6 months they took the material out from the warehouse when they required to use it. But that time they observed that inside the drum the material became solid. So they opened the cap and they kept the drum in a air dryer as they wanted to melt the material. So they kept under air dryer at around 50 to 55 Celsius for 16 hours long. After that, they observed that very trace quantity of the material became liquefied, but rest of the quantity remained as solid as it was inside drum. Now they bring back that material temperature to room temperature. That time they collected that small quantity of liquid and kept the drum closed with the cap. But after 15 to 30 minutes, they saw that drum ruptured completely and a white gas started exiting with force. And immediately that lab got filled with that white gas, and that gas evolution ceased after around 15 minutes. So it was a serious safety concern, but fortunately that only one occupant was there inside lab, and that person could exit from that lab. So no injury happened. But as it was a serious safety concern, they wanted to investigate what actually happened. First, they wanted to record NMR spectra of both solid and liquid sample. So they checked that liquid sample was completely soluble in CDCl3, but that solid material was completely insoluble in CDCl3. And the liquid sample, they measured proton NMR spectra, and it was identical with the actual molecule para-Trifluoromethyl aniline. That solid material then they tried to make soluble in DMSO D6, and they found it is soluble, but the NMR spectra is different from the original molecule. They tried to analyze that elemental analysis for that solid material, but it was inconclusive. Next, they tried to liquefy that material by applying heat, and observation was like the solid softened at 170 Celsius and melts at around 225 to 230 Celsius. Now they started to investigate the actual melting point of that aniline derivative from some literature, and lot of discrepancy they observed. Like in literature it mentioned melting point in some literature 3 degree, even in some literature 38 degrees Celsius also. So correct melting point information they were not getting. So for that reason, they wanted to freeze that liquid sample to get correct information about the melting point. And they observed that melting point is actually ranging in between 3 to 8 degrees Celsius. They also found that it actually solidified at around 1.5 degrees Celsius, and during that solidification process, temperature immediately shoots up to 7.5 degrees Celsius. Now that frozen solid from that sample, liquid sample, also they recorded proton NMR spectra, and it is identical with the original molecule. Next, they have performed some DSC study of that unwanted solid material from the drum, and they observed exotherm at 296 joule per gram at 87 Celsius. And for the fresh aniline derivative molecule, they got information exotherm at 419 joule per gram at 182 degrees Celsius. And they had also one liquid sample of that pure CF3 derivative of aniline. They stored for more than a year at room temperature, and it became little amber color. For that sample also, it was 419 joule per gram at 138 Celsius. And further analysis they attempted was mass spectroscopic analysis for the solid material, and observed mass was 423, where the mass of para-CF3 aniline molecule I mentioned in first slide 161. So this observed mass is around 3 times. So based on this mass observation, they proposed two possible structure for that unwanted solid material, structure 1 and structure 2. These molecules are kind of trimer of the original molecule. One is cyclic, another is acyclic structure. And from the fragmentation pattern of the mass and from the NMR spectroscopy, they concluded that structure 2 is the most likely material structure for the unwanted solid material. And the evolved gas is most likely to be hydrogen fluoride. And hydrogen fluoride, you know, it's a very toxic gas. Eye exposure to this hydrogen fluoride may cause long-term or permanent vision problems. And inhalation of this gas can cause serious respiratory problem. So it was kind of a serious safety concern. This evolution of HF supported by one literature also, like they found one literature where they mentioned that structure 2 compound can be synthesized from this para-CF3 aniline molecule with the elimination of fluoride. So overall, from this observation, they concluded that heat of crystallization or any autocatalytic decomposition of the material caused the incident. And the key takeaway message from this incident is like the molecule para-CF3 aniline should be stored under controlled condition, and the material should be handled very carefully, especially if anyone is handling bulk quantity of the material. And this report was published in OPRD journal in 2001 by Pfizer R&D team from USA. If you want to learn more about the incident, you can go through this literature. Thanks everyone.